After studying derivatives in details, we then go into something called antiderivative. So basically, we're reversing everything we've done with the derivatives. So if I have a function f that integrates to give an f of x, it means that this f is an antiderivative. Now, I'll start with this video with very vague wording, but then we're going to make everything quite formal. Now, always remember antiderivative is just the opposite of deriving, so you're moving backwards. This is an informal definition of what we're going to look at now. So, for example, if my function is x to the power of n, so moving backwards, just think of the function that would derive to get it back to x to the power of n, and that would be increasing the power and divided by n plus 1. And we add something called a plus c because we don't know if there was a constant that got derived or not. Now, a lot of this seems a bit odd. It's only after we see examples that I would recommend going back to what I explained here to understand what was happening. So, for example, if I want to go back to a function that derived to give x to the power of 8, well, I know that the derivative reduces the power. So in this case, I'm going to add the power. So we're going backwards. But if I derive this, let me check my answer. The derivative should give me this. If I derive this, it's going to give me 9x to the power of 8. But there's no 9 here. I need to make sure that if I derived it, the 9 gets eliminated. So I have to make this over 9. So now if I derive this, it's going to be 9x to the power of 8 over 9. The 9 will cancel out, and you're going to end up with x to the power of 8. However, what if there was a number here that I didn't know about, for example, 2 or 3? Because the derivative or 2, 3, 5, negative 15, 100, all of those would derive to a 0, which is obviously not here. So that's why we add the plus c, because you never know. Maybe there was a constant here that derived to a 0. Maybe there wasn't, but we always add the plus c here whenever we do antiderivatives, because of the possibility of a constant being there, and we use the c for convention notation. Now we do the same thing here, so this is the rule. You always add the power and you divide by that new power. So let me just rewrite this as x to the power of negative 3. I'm going to use the rule again. I'm going to add the power, so it's going to be negative 2, and then divide by the same negative power, so that will be negative 2 as well. And now if I derive it, I can rewrite it as well, 1 over negative 2x squared. If I derive this, the 2's will cancel out, and I'll end up with an x to the power of 3 in the denominator, so I end up back here. This can be rewritten as 3 over 5, and you'd follow the same exact rule. The antiderivative, you add the power, and so you're going to have x to the power of 3 over 5. You're just going to add a 1 into it, so that's going to give you a 8 over 5. And then you want to divide by that amount, so divide by 8 over 5. Now, dividing by a fraction is very odd, but just remember the fact that if I'm dividing by 8 over 5, it's the same as saying 5 over 8, and that's something you'd learn like all the way back in middle school, elementary school. So this would actually be 5x to the power of 8 over 5 over 8. So just to rewrite this, whenever you're dividing by a fraction, just reciprocate the fraction. And then we don't forget the plus c, and in here as well. If you don't add the plus c, it is actually wrong, because not adding the plus c in there gives you one type of what the original function could have been. So you have to add the plus c to show that, oh, there's a possibility that there was a constant. Now, more formally, this is called an indefinite integral. This is where we go into integration. So the notation we use is this curly kind of, it looks like an S if you want to. And it's, if I want to find the derivative as we did before, sorry, the integral as we did before, I'll use this symbol and I'll tell you integrate my function. And this is called an indefinite integral. There are definite integrals, but we're going to look at those later. So what this means is I want you to find the antiderivative of f of x, just as we did before, with respect to x, or the integral of f with respect to x. Now, the with respect comes with dx. This dx just tells you what variable you're dealing with. So this is the full notation. So the integrand is your f of x. The variable you're going to integrate is d of x, and I'm going to explain why that's important. And then you have the constant of integration as well. So I would do something like our previous example. This would be how I would write it. And basically what it tells you is you have to find the antiderivative of this. This just tells you that x is what you have to integrate by. That's your variable. So that's going to be x to the power of 9 over 9 plus c. And in here we're using the power rule there. So these are I'm going to compare the derivative rules and the integral rules. So the derivative rule, this is taken from the Math Oxford Standard Level AA book. So the power rule, we know what the power rule is in derivatives. You reduce the power and you multiply the coefficients by the power. In the integral rule, we add the power and we divide by the new power, and then plus c. So just to compare the two rules. In derivatives, we have that if you are multiplying by a constant, I could take the constant out and just find the derivative of the function. And the same thing happens with integrals. If I'm multiplying by a constant, by a function, I can actually take it out and just integrate the function itself. And actually it makes the integration much easier because you'll be dealing with smaller numbers, for example. Same thing with derivatives, you're allowed to derive two separate functions, and the same thing with integrals. If you have two separate functions, you can just take the integral of one function and the integral of the other. There's no special thing that you have to do if two functions are being added. You just do the integral. And then the final answer would have just a final plus c in the end. Constants derive to a 0, which means that if you're integrating constants, it's not going to integrate to a 0. Actually, it's going to integrate to a kx. So just the dealing with constants in derivatives is different than dealing with constants in integrals, just to be aware of that. And as usual, everything has a plus c in it when you integrate. So refer to these rules and look at the following examples. So I would recommend you pause the video, try these examples. I'm going to reveal the solutions and just a brief commentary on how to approach each one. So these are the solutions to each one. I'm going to just pinpoint a few important things. So this is where the variable matters. When I tell you integrate 6 by du, the variable you have to include is not necessarily x. The question wants it in u, so you have to write the u in there. So if it's du, you're going to write 6u. If it's dt, you're going to write 6t. If it's going to be dx, then it's 6x. If it's going to be dr, then it's going to be 6r. So you don't just write any letter and you don't just write x. You have to look at what variable you're integrating by, and it usually tells you by that d and then whatever this letter is next. So that's something to note. This is where you take the constant out. So 2 integral x cubed dx, you're going to integrate this, and then your answer is going to be x to the power of 4 over 4 plus c. And then you just simplify your answer. So it's going to be x to the power of 4 over 2 plus c, which is why we have the plus 2. In here, you're doing each integral on its own. And yes, you might end up with like t to the power of 4 plus c plus 2t cubed plus c, and so on. So you have a couple of plus c's, but eventually you can combine all the c's together into one big c, because c is just a number. Like, you're just adding numbers. If I tell you c is a number, it doesn't matter if it came from 3 plus 5 or it came from 3 or it's actually just 5. I don't care. It's just a number. So I can actually add all those constants together into one c. So that's something to note. In here, you're doing different combinations. So you're splitting it up. You're taking this and then you're taking that on its own. And again, you need to be aware of the plus c's. All the rules come in together, and the more you practice, the more fluent you're going to be. So have a go at more questions like these for basic integrals.